For the second part of Chapter 7, Section 1, we will be talking about functions. Functions are defined as if an equation in two variables, x and y, yields precisely one value for y, for each value of x, we say y is a function of x, or that y depends on x. So what we have when we use function notation is we normally have been using this first column, y equals notation. So we had y equals 2.5x. Or if x equals 10, then y equals 2.5 times 10, which is equal to 25. So we can still use that, but function notation just makes it a little bit nicer. So if you go to the second column to the f of x equals notation, this notation is read f of x, and it just means it's a function. We won't prove that anything is a function, we'll take it as is. So instead of saying y equals 2.5x, we have f of x equals 2.5x. What happens is the f of x just replaces the y. So then in that last row, we have f of 10 equals 2.5 times 10 equals 25. Or f of 10 equals 25. So what happens with this function notation, that anything inside the parentheses is going to be replaced with your variable, or whatever's in there replaces your variable. So it might be a number, sometimes it might be another variable, sometimes it might be an expression. So you could even plug in x plus 2 in for x. Another way to determine if something is a function is by the vertical line test. This is a pretty nice one. So if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. And again, we're not going to get too in-depth with that, but if you had a graph, you could easily tell by drawing a few vertical lines to tell if it's a function or not. So for our first example, we're going to find each of the following. So it says find f of 4 for f of x equals 2x plus 3. So f of 4 just means find f of 4. Anywhere where you have that x, it's now going to be replaced by 4. So it's going to be 2 times 4 plus 3. If you'd like, type that right into your calculator. You will get 11. For the second one, it says find g of negative 2 for 2x squared minus 3. So again, anywhere you see an x is where you're going to plug in this negative 2. So it's going to be 2 times negative 2 quantity squared. Recall from earlier, I can't remember what chapter, but remember when we plug in a negative number, please make sure you put that in parentheses, especially if you're squaring it. If you don't put those parentheses in, the calculator will not read it the way you want to. So it's going to be 2 times negative 2 quantity squared minus 3. Plug that right into your calculator, and you should get 7. For this next example, it says use the line graph to estimate a car's required stopping distance at 40 miles per hour on dry pavement. Round to the nearest 10 feet. So first off, we're just going to use this graph to figure out the stopping distance. So on our x-axis, the horizontal axis, it's the speed, and then this y-axis is giving our distance. So it says the car's required stopping distance at 40 miles per hour. So you're going to go over to speed, that's a speed, go over to the 40, which is going to be right here. Go up until you hit the graph, and that's going to be this point right here. So it looks like the stopping distance is about 200 feet if you go over to the corresponding y value over here. So then, this is our graph. We also have a function that models this. So the function f of x equals 0.0875x squared minus 0.4x plus 66.6 models a car's required stopping distance f of x in feet on dry pavement traveling at x miles per hour. Use this function to find the required stopping distance at 40 miles per hour round to the nearest foot. So we're doing the same thing, but we're using a function to figure out our answer rather than a graph. So does this 40, is that going to go in for x, or is that going to go in for f of x? X is miles per hour, f of x is distance. and it says 40 miles per hour, so it's going to be x. So x is equal to 40. So what we're going to find is f of 40 equals 0.0875 times 40 squared minus 0.4 times 40 plus 66.6. You can type this right into your calculator, and if we round to the nearest foot, it looks like I am getting 191 feet. And again, please label your answers. So the first part A I should have labeled as well, so that should be feet as well. So again, pretty close. The graph, a little less accurate. If we zoomed in, it might be a little bit more obvious, but this function gives us the exact stopping distance where the graph gave us an estimate. And then for our last example, it says when a person receives a drug injected into a muscle, the concentration of the drug in the body, measured in milligrams per 100 milliliters, depends on the time elapsed after the injection, measured in hours. The figure shows the graph of a drug concentration over time, where X represents hours and Y represents the drug concentration at time X. So for part A, it says during which period of time is the concentration increasing? So we read graphs left to right just as we would words. So reading left to right, increasing is going to be where it's going up from left to right. So it looks like it's increasing in this area. So that looks, and it's a little bit hard to tell. If you can zoom in, I'm not really sure if that's possible. But if you look closely, it looks like it's about 0, and I'm trying to look really closely. It looks like 3 hours. So from 0 hours to 3 hours, the drug concentration is increasing. And let's just double check. Yep, so it looks like it's 3. And then during which period of the time is the drug concentration decreasing? So what we're looking for there, sorry, I was trying to erase that. What we're looking for there is reading left to right that it's going down. So it looks like that area is going down. So that's going to be from 3 to 13 hours. The concentration is decreasing. Then it asks, what is the drug's maximum concentration and when does it occur? So we're looking for the highest dosage, which looks like, and that's going to be our peak. So that looks like it's going to be right there, which is going to be 0.5. And it's kind of a weird label, but 0.5 milligrams per 100 milliliters. And we're looking for when that occurs, and that peak is occurring at that 3 hours, which happened to be where it went from increasing to decreasing. So that's a good sign. Then it says, what happens at the end of 13 hours? And I'll let you, there are a couple different answers, but at the end of 13 hours, the drug has left your body. So there's no more concentration left. And then E says, explain why the graph defines Y as a function of X. And why it does is because as time passes, your concentration of the drug is dependent on how much time has passed. And that is exactly why it is a function.